So where are we going here? Just kind of look at the topics. We're going to go back to a couple things. We're going to look at the Cartesian coordinate system, which is graphing. We're going to take a look at what we call writing equations of lines, which is an extension of graphing. So this is going to use a lot of your material on the order of operations, PEMDAS, and solving equations. And solving equations. Solve EQs. Okay. Like you did back all the way in the first part of the course. So this is going to heavily rely upon all that stuff. And same thing here. Same thing here. It's going to utilize the same material. So where we're going is we're going to be dealing with equations with two variables. We're going to be drawing lines and we're going to be doing some manipulation, but it's just solving equations and order of operations, kind of a different look of it all. So that's where we're going in the near term with this stuff. Oops. So my point is the recent stuff on factoring, on quadratic equations, on rules of exponents, we're not going to do that for a while, for a couple weeks. Probably once we get towards Thanksgiving-ish, maybe a week before, we'll start going back to that stuff just a little bit, but not as heavy and extensive. The next couple weeks is definitely going to be solving equations and order of operations like you did back in the first 2 weeks of class. And so I think it'll be a little more familiar. So I just kind of want to point that out there. So just to kind of quickly wrap up here the stuff on geometry, excuse me, this one is really, it's the same thing. Order of operations is the main tool you'll use. The key here is to identify what formulas you need. And typically we're dealing with either the perimeter, the area, or the volume. And remember, perimeter is a round, area is the stuff inside of a two-dimensional object, volume is the stuff inside of a three-dimensional object. So you have to know what shape you're dealing with, and then are you dealing with the area or perimeter, and then what's the formula for that thing? And if you ever forget, I would just recommend Google it. It's not something that you need to crowd your memory with. Feel free to just look it up and say, hey, what's the formula for the area of a trapezoid? What's the formula for the area of a cylinder? Or I'm sorry, volume of a cylinder, something like that. Perfectly fine, because candidly, I still have to look it up too. These are not things I've committed to memory, to my long-term memory. This one was a good problem. If you notice, it's an amalgamation of shapes. It's a joining of shapes, and so sometimes here, and we'll do another one similar. But the point of this is that you have two shapes here. You have two shapes here. You have a triangle that is joined with a half of a circle, a half of a circle. So sometimes you'll have to combine shapes. Is what the moral of the story here is in essence, break it apart. Break it up into things you know how to do. It's like pieces to a puzzle. Well, I know this piece, it's a triangle, and I have this piece, it's a circle. You put it together. So let's see if we can do a try similar. Okay, so it's a similar thing here. Half of a circle with a triangle. And remember, the approach we used was to say, well, they want the area, the total area, okay, but there's two shapes. And so we're taking two shapes and joining them together. And when you hear the word joining, the operation is addition. So we're taking the area of the semicircle and joining it, meaning adding it to the area of the triangle, okay? So what you want then is, what's the formula for the area of a semicircle? Well, semi means 1/2, okay? Well, let me do it this way. What's the area of a circle? Pi, let's see if I can do it. Pi, there it is, pi r squared, pi times r squared. Now that's the full circle, so we need 1/2 of that. Plus area of a triangle. Well, if you got to look that up, that's 1/2 times the base times the height. I'm seeing now my video is off. So notice here, I did it again. It doesn't like when I do that. They were good, thank God. Okay, so I just noticed my video wasn't on. So notice one thing I did here. is you may be asking yourself, how in the world did he get this formula here? To take note of is I don't know that formula off the top of my head. What I did as I looked at it piecemeal, I said, okay, I need to know the area of I need to know this area right here. That's my first piece. Oh, well, that's a half of a circle. And so that's what this part right here represents. So I took that, I just focused on that piece. And then I said, oh, well, the remaining shape here is a triangle. So I need that area as well. And I took it that one piece at a time, one piece at a time. So then the other thing now that we need to, now let's actually digest it and do it. So in order to do the area of a circle or the half circle, the only thing we need to know is what's the value of r. And r is the radius. R is the radius of a circle. So the radius of a circle is uh, the distance from the edge to the center of the circle. Okay. The diameter, on the other hand, is the distance from one edge of the circle to the other going through the center. Okay. The radius is 1/2 of the diameter. Okay, so those are the things we need to know in order to do this one. So this thing here, we have a value of 19.7. What does that 19.7 correspond to? Well, if you notice, it goes from one side of the circle to the other side of the circle, going through the halfway point, going through the center. So this 19.7 corresponds to what? Corresponds to the diameter. Okay, so 19.7 is the diameter. So the radius is just 1/2 of that value. So we got to take 1/2 of that value right there, and that gives us what? I don't know. Calculator time. 9.6. 9.6. So we have the area equals 1/2. Now pi, the directions tell us to do 3.14. And the r, the radius we determined here, is 1/2 of that 19.7. So we're going to use the value of 9.6, and we have to square it. And then now the second part, 1/2 times base times height. That's 1/2. Now the base of a triangle is the bottom, typically. So what you do is you take that triangle and you just kind of mentally flip it up, make the point, just turn it around and make the point shoot up. So that 19.7 also serves as the base of the triangle. You know, it's the same side, the same thing. And the height is the vertical height, vertical up and down, 17.8 in this case. So all we did there was we just filled in the values. Now it's just straight calculation time, straight calculation time. And this is where you're going to use your order of operations, PEMDAS, okay? And so remember about PEMDAS? Oops, excuse me, that's a D. Okay. Got bad handwriting. PEMDAS. Okay, so we don't really have any parentheses, but we do have exponents. Look, right there, we got an exponent. So let's do the exponent first, and then we're going to do multiply, divide, and all that stuff. So I'm going to sort of leave it to you, but when we do this, area equals 1/2 3.14 times 9.6 squared. That's going to be 92.16. So if you're going to do it, you know, piecemeal. Now we can do our multiplication. So 1/2 times 3.14 times 92.6 is 144.6912. And notice I didn't round. I kept all my decimals. So that's a recommendation, by the way. Don't round until the very end. And so this one, the other half, 1/2 times 19.7 times 17.8 is 175.33. And then we add those together. Oops. 320.0212, and the directions say round to the nearest hundredth, which means they want to go to the second decimal spot. So we look to the third decimal spot to see if we need to round up or down, and we don't. So this is the answer, 320.02. So sometimes you just have to do a piecemeal approach. Look at your shapes and kind of, yeah, gotta unlock the pieces. So let me pause here. Any questions on this one?
I just wanted to make sure. So the second to last step you did, you multiplied the 1/2 by both parentheses, the 3.4 and the 92.16, and then just added those together.
I did 1/2 times 3.14 times 90.92.16. Is that what you're asking?
Yeah. So you did 1/2 times 3.414, and then whatever that answer was, you multiplied the 92.16.
Yes, yes.
So you didn't do 1/2 times the 92.16 separate and then add them
No,
together.
right,
Okay.
right.
So just all together.
Anybody else? Let's go forward and see what else they have because a lot of this stuff is now just sort of the same thing of identifying the shape, perimeter area, what's the formula, fill in the formula. That's the steps. Identify the shape. Are you finding the perimeter area? What's the formula you need then? And then fill in the formula. It's kind of the way it goes. So look at this shape. What's this shape? So let's go through that. What's this shape? You're probably thinking to yourself, I have no idea. But it tells you in the problem. It's a trapezoid. It's a trapezoid. It's kind of an odd shape. So if you ever see you see trapezoids all the time. You just probably don't realize it. Look at the roof of your house. Trapezoid. Oftentimes, go up into the attic. You'll probably see it there too. Anywho, so this is a trapezoid. So that's the first thing. What's the shape? Trapezoid. Area or perimeter? Well, the problem tells us. In this case, it tells us the area. Okay, so we need to go look up. Hey Google, tell us what is the formula for the area of a trapezoid, and you will find its area equals 1/2 the height times what we call base 1 plus base 2. Okay, the height is what it means, vertical distance, vertical distance. So we have three values here, 16, 18, and 26. Which one do you think would best represent the height in terms of vertical distance?
18.
18. That indeed is the height. Right. Now the base 1, base 2, all that means is the top and the bottom of the figure. Okay. Top. Typically, in the trapezoid, the base 1, base 2 are the flat lines, the ones that are parallel to each other. Notice this line is parallel to this line. That's what we're calling our base 1 and base 2. So base 1, base 2, 16 in the 26. Does it matter which one you call B1 and B2? No, it doesn't at all. So I'm going to call this one B1 and I'm going to call this one B2. Okay. So now plug everything in. Area equals 1/2 the base, which is 18. I'm sorry, the height is 18. Base 1 is 16 plus 26. And let's, order of operations, order of operations. Once you've got it filled in, now it's the order of operations. So this becomes area equals 1/2 times 18 times, looks like that's 42. And now we can multiply. 1/2 times 18 is 9, times 42 is 378. So that's the answer. Area is 378. Boom. That's the answer. Let me check in with you. Questions on this process? And like I said, I'm going to just keep reinforcing it. Don't stress out about memorizing the formulas. You may want to keep a list of them so that because when it comes time for the test, you won't have to go Google it. You can have your list right away. And you can probably find a cheat sheet on the internet. I used to do that all the time. Hey, give me, and I look for it. What's a cheat sheet for all these formulas? It's out there. I know it is. So let's go ahead and leverage the internet to help you out on getting a resource.
I'm not sure, but I think if you hit tutor, I know like if you get an answer wrong, I always hit display answer. I click on it and it gives you like yesterday it
Okay.
gave me like all the I don't know if it gives it to you on there or not.
Yeah. So here it
Uh,
is. This is the formula. So they say 1/2 h plus b plus times b plus c. Okay, that's fine too. That's a perfectly acceptable way of saying it. So that's a good point. Uh, so just to, yeah, I like to reinforce that. Use the tutor feature. It's good. I find a lot of students have found it helpful, and hopefully you are too. Oops. Back to practice. Okay, one more. Let's see what they got. So then the rest of it is just sort of properties. Every rectangle is a parallelogram. I'm not going to tell you the answer to that. You can use Google to help you out with this, but this is kind of going over the properties of it. What does it mean to be a rectangle? A rectangle has a specific meaning. A parallelogram has a specific meaning, and sometimes they overlap. One becomes the other. So a rectangle is what? A quadrilateral, meaning four sides, with two sets of parallel lines, okay, and then at least one right angle, at least one right angle. Could be more, there will be more, but at least one. A parallelogram, on the other hand, is a quadrilateral, four sides, with two sets of parallel lines, but there's no requirement that it has to be, you have to have a right angle. So with those definitions and characteristics in mind, you can start drawing some conclusions. Is a rectangle a parallelogram? The answer is no. But is a parallelogram, I'm sorry, a rectangle is a parallelogram. That's true. But a parallelogram is not always a rectangle. So there's some things you can say. So every rectangle is a parallelogram for sure, yes. Um, but not every parallelogram is a rectangle. It doesn't work the other way. Squares, every square is a rectangle, but not every rectangle is a square. Why is that? Do you know? Every square is a rectangle for sure, because it has four sides, two sets of parallel with one right angle. But what's different between a square and a rectangle? In a square, all the sides are the same length, but in a rectangle, you have the length and the width can be different. So it's those little things. You're just taking the definitions and sort of characterizing and say, oh, we get these nice, cool little things that come out of it. So that's what this is all about. No calculations per se. Volume, okay. So when we think about perimeter, area, and volume. What are you doing? Perimeter is distance around. It's a one-dimensional object, a one-dimensional distance. One. It's a measurement in one dimension, just straightforward length, if you will. Area has two measurements, two dimensions, length and a width. Okay, so that would be a square, a rectangle. Okay, uh, volume is a three-dimensional measurement, length, width, and height. And so we say that makes a cube. That's how we get all this stuff, by the way. A square, square units, and then a cube, cube units. Oops. So that's how they do it. So it looks like a cube. So volume is measured in cubic units, just to kind of give you a heads up. So one dimension, just straight unit, two dimensions, squared units, three dimensions, cubed units. And so now it's just going on a lot of properties here. Find the volume of the solid. This is the same sort of thing. What's the object? Are you trying to find the perimeter, area, or volume? What's the formula? So here we have a rectangular solid, okay, and we want to find the volume. So the volume, that formula then, I want to find the volume of a rectangular solid. Go to Google, and it will tell you its length times width times height. Well, let me do it. There we go. Length times width times height. So we got the three values, length, width, height, multiplied up. Looks like it's 540. I'll leave you to do the answer, but it's just more of the same, more of the same. So I'm going to go ahead and exit this one, unless anyone has any questions about the geometry or what you have to do. But it really is those four steps. What's the object? What's the shape? Area, perimeter, or volume. Go find the formula, fill it in, and then simplify. All right. Let's uh let's start taking a look then at the kind of the new stuff then. And that new stuff is really kind of gonna we're gonna be living with it for like one, two, three, probably for this through next week. Yeah, because then we got to do functions after that, and functions are pretty cool. Uh, I think they're cool at least. Okay, the Cartesian coordinate. So you got two things on the Cartesian coordinate system. So we'll kind of take a look at that. Hopefully, I can do some graphing here because I'm terrible at drawing the graphs. When you got bad handwriting, it's just really bad. Can be. Let's see. Ah, awesome. Good. It's got the graph for you. Okay. So we live in Lafayette, and you live in South Louisiana with a lot of, the thing about our area is we're cut up by a lot of rivers. Go to New Orleans, same thing. So you don't have a lot of grid, but if you go to Houston, you're going to see grids. You go to New York City, you see grids. A lot of large cities, their downtown have grids. So the thing here is what we want to do is the Cartesian coordinate system is a way that we can sort of turn an equation, something like this, 2x plus 3y equals 4. I don't know, just making something up. We want to take an equation sometimes and we want to see what it looks like in a picture. We kind of want to do the translation because there's some cool things you can do with pictures. But we have to have a methodology for getting there. And a mathematician about 400 years ago gave us a way to do that. And what he did, his name was Rene Descartes. If you ever have you ever heard of the phrase "I think, therefore I am"? He's a philosopher. He was a French philosopher too. A lot of mathematicians were philosophers, and even today, a lot of philosophers are mathematicians too. Anyways, that's besides the point. What he did is he says, "Hey, you know what? We have this number. I have this horizontal number line here that I use already to measure distance. What's the distance from this point to this point? What's the distance between the two? Okay. Sometimes I want to use length. What's the distance from Rome to Paris? Things like that. I already move in a horizontal fashion in a lot of ways. But what he sort of figured out was to say, hey, look, if I take this three-dimensional world and I turn it onto a map and I'm looking at a map, I can calculate distance that way too on a map, but I can't go in sort of a meandering fashion. So what he did is he created another. He said, well, let me just take another number line, a vertical, and put it in a vertical fashion. So kind of think of this as you've laid a map out on the table and you want to move. Okay, that's what we're trying to do. And so you're trying to approximate where on the surface someone is. Now the rules to the road is that you can't move diagonally. You can't move in a circle. That's not possible. Rather, all you can do is you can move in a horizontal and vertical fashion. Okay, so you can only make left turns and right turns. You can only make left turns and right turns. That's the point of this whole thing. And so making only left turns and right turns. Oh, and then yeah, left and right, up, down, things like that. But you can't move in turns. You can't go diagonally. How can we navigate through this whole thing? Now, even though we can only go, make certain things, we can create a diagonal shape. I can go this way, I can turn up, I can go this way, I can turn up, I can go this way, I can turn up. And by doing that, notice I can create, oops, excuse me, I can't really draw it here. It's not going to let me do it, but let me do this. Let me get a line. What I can do is I can connect those dots where I turn, and that does create a linear fashion. It does create a line. So that's the whole idea is I can move in this stair-step fashion to move along a linear path, to move along a straight line path. That's sort of the idea behind it. Now the way that we do it is we have to connect dots in space. When we turn somewhere, we're going to leave a dot behind, leave a dot behind, leave a dot behind. So those dots are the points of interest. That's how we're navigating through. And those dots are what we call ordered pairs. They're going to be represented by ordered pairs, okay? And ordered pairs are of a specific format called x comma y, x comma y, where x is the direction you move in the horizontal way, and y represents the vertical movement that you make, the vertical movement that you make. And we call it ordered, by the way, ordered, because x always appears first in the ordered pair and y always appears second in the ordered pair. So the first number always tells you your horizontal movement, and the second, what we call value of the coordinate, um, tells you your vertical distance, okay, where you're at vertically. The center of this whole thing right there is called the origin. It's called the origin. The origin, okay? It's the beginning of all graphing, okay? Whenever we want to make a picture, we have to start at the origin first, okay? So we'll talk more about that in just a second. Now, before we get to the origin, let's actually talk about ordered pairs a little more, okay? So suppose I put a dot right here. Suppose I put a dot, say right here, okay? What is the ordered pair that corresponds to this dot? What is the ordered pair? What's the x value and the y value? Now, if you notice, it we have hash lines right here, hash lines, okay? And we have hash lines going this way, we have hash lines going this way, and then so forth. And the center of where the two vertices meet, the center where they meet, notice that corresponds to 0 along the x and 0 along the y. This is the origin. This is the origin, 0, 0. The center of it is 0 along the horizontal direction, and 0 along the vertical. So the left of it are negative values. To the right of it are positive values, okay? And similarly, going up is going to give you a positive value. Oops, wrong way. Going to give you a positive value. And then going down is going to give you a negative value. So one of the things you want to sort of start to develop is that when we take a look at this, to move in a positive direction means you move either right or up. On the flip side, moving in a negative direction means you're moving either down or to the left. Down or to the left. And that's typically the case whenever we're in sort of word problem scenario. Think of it this way. If you're moving up, that's in a positive direction, down, negative direction. For those of you who have ever been to like Death Valley, not LSU Death Valley, but the true Death Valley, the desert in California, that's below sea level. Or New Orleans. New Orleans is below sea level. So if you were to draw a straight line to where the river is, the Mississippi River is in New Orleans, some of the city would be below it, below sea level. Well, that's in a negative direction. You're digging a hole. So a good bit of New Orleans is in a hole. But Death Valley is the same thing. It's the lowest point. Okay. So the first takeaway is that this ordered pair, this at the center, the origin, that's the ordered pair 0, 0. 0 in the x, 0 in the y. Okay, so let me go back to my dot right here. What's the xy ordered pair here? What's the xy ordered pair? Well, the way that we do it, the way that we get it, is you just sort of drop it. Go from the dot and just drop over to the x-axis and see where you hit, okay? And similarly, go to the y-axis and see where you hit. So the value on the x that we hit is the value of 5. What's the value on the y-axis that we hit? Y'all see it?
3.
3. Yeah. If this is going to be 0, then we move 1, 2, 3 units up. That's exactly right. And so that gives us the ordered pair 5 comma 3. 5 comma 3. That's how we do it. So let me give you one. Let me put a dot right here. Uh, what's the ordered pair for this one right here? I'll label it A, kind of so we can make it easy. What's this ordered pair here for? I'll call it A.
-3, +2.
It is +2. That's right. I couldn't see it. Couldn't see it either. Right. So drop down to the x-axis. That is -3, and then run over to the y-axis, and it hits at +2. Good. Let me give you one more. What's this one? I'll call it B.
Would X be 2 and Y would be 1, 2, 3, -3?
-3 because it's down. Right. Good. That's exactly right. Draw it up to the x-axis, see where you're at, and over. Good. Questions on that? On if I give you a dot and space, kind of what the ordered pair is, how to figure it out? Any questions on that? Because what we're going to do is then the reverse process. Suppose I give you the ordered pair 1 comma -3. How do we do it? Well, we got to just keep in mind, this tells me my x, this tells me my y. So what you do is you start at the origin, go in the x direction, turn, and then go in the y direction. So this says I want to go to the 1. So I'm here at the 1 at the origin. I go to 1, okay, first. So I'm going to go start at the origin and then go to 1 in the x direction. So I'm going to go right here. Turn, and I'm either going to go up or I'm going to go down. This one says what? I got to go to -3. So that's down 3 units. 1, 2, 3, and then stop and put your dot. Stop and put your dot. So we actually wouldn't have all that. We would just put the dot right there. So this tells you how far you run, left or right, and this tells you how much you rise, up or down. Okay. So you run in whatever direction, turn, and go up or down in your Y. So let me give you another one. Suppose I had the ordered pair -2, well, -2 comma 4. You tell me left, how far left, right, how far up, down.
From 0, you go to the left twice, and then you go up 4.
Left 2, up 4, right. Negative means left. In the X, it means left. So I go left 2, up 4, there's my dot. Left 2, up 4, right. So I'm going to put it right here. That's my dot. Right there. Oop, right there. So that's how it tells you. So okay, so that's sort of the thing with taking an ordered pair and turning it into a dot. That's sort of the fundamental thing that we need to know how to do. Let me give you a couple more. And these are not tricky, but it's just things that will come up. Things that will come up. Let me give you the ordered pair 5 comma 0. What does this say? Left, right, up, down. What would you say? How would you say it?
Right, and I don't know.
Right 5.
Would you go back to the left?
You would just stay on the center line, wouldn't
You'd
you?
stay. Yeah, so you go right 5, and this says move 0. 0 up, 0 down, 0. So you just stay where you're at. So you just move 5 and you don't turn, you're there because you move 0 up, down. So your dot is going to be right here. It's going to be on the axis itself, on the x-axis itself. This value, because the y is 0, because the y part is 0, we call this, and you see what axis is it on? It's on the horizontal axis, or what we call the x-axis. We call this the x-intercept. When we get to lines, the equations of lines, this is a special dot. It's the x-intercept. It's the dot where the line crosses the x-axis. And the unique thing about it is that the y part, the y component, is 0 because you're not moving off of it. You're not moving off of it. You're not moving up, you're not moving down, you stay on that x-axis. Similarly, I'm sure you know, you can see what's coming now. Let's do -2. Oops, not -2, sorry. 0, -2. So what does this one say? Right, left, up, down. How would you say it in words?
From 0, you go down 2.
Just down. You don't move left or right. You're locked in. So remember, you're here. It says move left, right, 0, and go then down 2. Boom. There's your dot right there. So similarly, so here's our dot. Okay. The x value here is 0. When you have an x value of 0, what you're dealing with is what we call the y-intercept, meaning the point on the y-axis where the line hits. Okay, so when you see 0, you're dealing with a special point. It's on an axis. If the y component is 0, that's your x-axis. If the x component is 0, it's a y-axis. Okay. So a lot of fundamental stuff we have to deal with when we first start out. So let's see. So this one, plot the following points. So we want to actually turn these into dots. So this is the stuff that we've been doing. Okay. And we'll do the first one, 7, 3. How would you say left, right, up, down with 7, 3?
Right, and then
Right, what? Right, how many?
7,
Right, 7,
and then up 3.
up 3. I'm going to use, well, I'll do up. We do up. Right, 7, up 3. Good. So when we do that, come down here, right 7, so here's the 7 line, and then up 3, there's my dot right there. That's what this question is all about. Taking the ordered pair and turning it into a dot, plotting it on the point. Questions on that? Not too terrible. Not too terrible. It gets a little terrible down the road, but right now, for the most part, I think you're going to like this stuff. This is not a uh, uh, it's a nice break. So one thing we can do, let me kind of go back. Well, let me do this. I can just do it here. The notion of quadrant 1, quadrant 2, quadrant 3, or 4, or the axis. Okay, that's the sort of thing when we were talking about a little earlier, or in the back on the back page. If you notice, the grid makes what we call 4 quadrants, and we label them. Quadrant 1 starts in the top right, and you go counterclockwise. Quadrant 2 is the top left. Quadrant 3 is the top right, bottom left, and then quadrant 4 is the bottom right, okay? So if you have a dot, let's say 6, 5, right 6, up 5. So right 6, up 5, there's my dot. That's in quadrant 1. That's going to locate itself into quadrant 1. That's what they're asking here, is which quadrant does that dot land on? The axis is if you have a 0 for your x or 0 for your y. That's what we're talking about with the intercept. It's on the axis, either the vertical or the horizontal axis. So that's what that question is all about, is just asking, hey, where does this point exist? Which quadrant does it exist on? After this lesson, we don't much care about the quadrant anymore. I almost never use it. Okay, so this is what I was mentioning earlier. As part of our work with lines with 2 variable equations, you're going to have to sometimes use your order of operations. You're going to have to sometimes use your skills for solving equations. So before I dive into this, just kind of one thing to take note of is that when we're dealing with uh, the graphing, okay, what we're trying to do is we're trying to turn an equation like this, say, into a line, okay, into a line. Now, if you were to take a picture of that line and just keep zooming in, just zoom, 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 zoom until you cannot zoom anymore. If you were to go infinitesimally small and really get a hone in on that zoom, what you're going to see is you're not going to see a line. You're going to see a bunch of dots, okay? You're going to see a bunch of dots arranged in a linear fashion, okay? That's what you're going to see. It's just a big composition of dots that are just so close together, and there's so many of them, it bleeds and looks like a line when you step back from it. Okay, the point of all that is, remember that famous phrase, the shortest distance between 2 points is a straight line? Well, the other part of that is you only need 2 points to make a line. So the exercise here is to take this equation and turn it into a line. And even though a line is composed of infinitely many points, it follows a pattern such that we don't need a lot of points. We just need 2 points and we can create that line, and it will predict the path of every one of those points. That's the whole idea behind it. The question though is hey, how do we generate the point? How do we find it? And the thing to be reminded of is that this equation here, 9x minus 6y equals 16, is nothing but a pattern. It's nothing but a formula. Just like the formula for the area of a rectangle or the formula for the perimeter of a circle or whatever it is. Those are formulas. Those are patterns. That's the same thing here. This equation is nothing but a pattern. It tells us the shape of our line. We use the formula and see what shape it corresponds to. So the gist of it is that in order to find this line follows a pattern determined by that equation. So what we do is, now let's come over here. Notice the chart gives us some values for x and gives us some values for y. But it also says, well, hey, here's the value for y, but there is no value. It doesn't tell us the value for x. We have to find it. So the cool thing about it is that this formula here is the way that we're going to find the missing value. So the other part of it is that every value has a unique pair. It's only paired with one thing. Okay, so this value of 0 for y will only have one other pair, one value of x that it's paired with. It's one and only one in this equation. Change the equation, you change the pairing. Okay, that's what dictates the pairing. So what do? We are given the value of y. So come up here into the equation and plug in that value. So what does that give us? So we start with the equation 9x minus 6y equals 16. Wherever you see the y, replace it with 0. And looky there. We only have one equation. We know how to solve that. Go all the way back. How do we solve this from here? How are we going to find x? That's the goal. At the end of the day, we want to find the missing value of x. How are we going to do that? I'm turning it over to you now.
6 times 0 is 0, so you can kind of just get rid of that.
So 6 times 0 is 0, right? So I can just get rid of that. Now what?
And then you divide each side by 9.
Right. Giving me 16 over 9. Okay, not pretty, but it's the answer. That's right. That's what's going to go in that blank right there. Right here.
Okay.
See it?
How do you graph that? I guess we'll find out.
Yeah, we'll find out. The short answer is you don't.
Okay.
We even though we can plot it if we want to, we don't like plotting decimals and fractions. We like nice, neat numbers. Okay, so let me skip ahead then to this one here. Oh. How about this one? How are we going to do this one? So go back to your equation, 9x minus 6y equals 16. Now where am I going to put that 2? In for x or in for y?
X.
In for x. Okay, tell me how to solve now. X is gone, I just have a y, I can solve it. And why solve? Because you see an equal sign. When you see equals, that means solve, typically. So what's first?
Multiply 9 and 2. We get 18 minus 6y equals 16. And we can
What's next?
subtract
Subtract what?
18 from both sides.
Right. So now we got to call upon our skills from solving equations, subtract 18 from each side, leaving what? Don't forget that negative in front of the 6. So negative 6y equals negative 2, and then what?
Divide each side by -6.
Right. Clear out that negative 6 by dividing, and so we get the answer, y equals 1/3. Don't do 0.33 unless it tells you to do decimals. Just use the fraction. Even 1/2, even for things like 1/2 where it's a terminating, it's a nice decimal. It's not a bad decimal. Even that, keep it as a fraction. So that's all you do on this one. Is just use the formula, use the equation to find the missing value. So I'm going to have to, so we're coming to the end here. Let's see. Okay. Let's see. Find the perimeter of the triangle whose vertices are this. Oh, this is interesting. So you have three, these are your 3 of your vertices, not all of them. But what you want to sort of imagine here is that you have the XY axis running through it. Okay, if you could. So where's 3, -8? Well, that's 3 to the right, 8 down. That's probably this one right here. Just kind of use your left, right, up, down. -1, 0 is -1 to the left. So it's right here. So, okay, so anyways, it's not going to fit this. It's not going to fit this perfectly. So let me kind of take it off. But that's sort of the idea. Is this one corresponds to 3, -8. -1, 0 corresponds to this one up here. And -2, -7 is 2 to the left, 7 down. So that's this one down here. So what is this? Oh, it's a triangle. I thought it was a rectangle. Okay, so here's the triangle. Okay. So now we have to figure out the distance. Something's off. I think I know. So how do we do this? This is interesting. What's this distance right here from -2 to +3? Well, suppose you're here at 2, so you're going to go, so remember you got to cross 0. So 1, 2 units to 0, 1, 2, 3 units to 3. So the total distance is what? You've moved 5 units. You've moved 5 units to get from -2 to -2 to 3. You go to 1, 2, 3, 4, 5. How many units do you move up this way? 7, 6, 5, -6, -5, -4, -3, -2, 0. So you move 7 this way. Do y'all see that?
Yeah.
Okay. So what do you know about a right triangle? What's the big buzz thing that comes up with a right triangle? You remember it?
Pythagorean theorem.
Pythagorean theorem, right. Right. So that's a squared plus b squared equals c squared. So what are we missing here? Where's the c? It's this right here. It's the missing piece. So use your values here. 7 squared plus 5 squared equals c squared. So that's 49 plus 25. That's something. Was that 84? 74? Yeah, it is 74. So take the square root of 74. Yes, got it. iPhone's wonderful until you need it, and then it doesn't want to cooperate. Like 8.6. So 8 point, it was the square root 74. That can't be right. Might have done something wrong. I may be going too fast. Oh, well, no. So now what's the perimeter? What's the perimeter? What's the perimeter? Well, you just add the 3 sides.
Ah,
7 plus 5 plus the square root 74. I mean, I'll check check my math on the 74, but maybe it's, so it could just be the 12 plus the square root of 74. Okay. All right, so this is going to conclude this part of it. I'll go back and check my work. I'll check this one again, but this is kind of how the first one works. It's just plotting points and trying to figure out the order of pairs. Not too terrible. We'll pick up with this on Monday and then start looking at equations of lines and writing equations of lines and all that jazz, as well as review for our test next Wednesday. So hope you have a good rest of your night. Have fun trick-or-treating, and I'll see you on Monday. Okay?
thank you. You too.
Bye-bye.